Are we recording? Yes, we are recording. Okay. Hello all and welcome to the week 8 of this sessions, Intro to Machine Learning TAA sessions. So we'll do the assignment 7 questions. Before that, so there were some pending questions from the last assignments, right? So I hope all of them have been answered. Anything that was unclear till now in the past assignments?
Sir, yes, I had few questions, sir, about what you answered also in our forum. So if you want, I can go that later once you have assignment 7 questions answered.
Sure, we can do it post assignments, not a problem.
Okay, thank you,
Okay.
sir.
Right. So let's begin with assignment 7. So first question, any thoughts? So what are we asked? We are asked to construct a most specific concept, but that too only using this conjunction of Boolean literals. And the instance space and example is given below. So what would be your first step in this find as algorithm? Anyone remembers? How would you
All
start this?
parameters are 5, like no value.
Okay. Post that.
Suppose that go for the first record with the which has a category yes, then replace them with uh, the values if they have any values. So replace color with red, shape with round, size with big, and texture with hard. And
Right.
now at the end of that round one, so it will be red, round, big, hard.
Right. And then you'll move on to the
And
next.
second one with category yes, and again since they have the both same values, so the
Right.
same values continue at the end. And next we'll ignore the third row since it is category no. Then we will go for the fourth row with the category yes, and for the first feature the color will be still red because still it has red, and the second feature will be still round. For the third feature also it will be still big. Fourth one texture, before it was hard and now this record has soft, so since then it will change it to question mark. It can take any value.
Can take anywhere.
So any value, and so then that will be the answer.
Right. So the answer that becomes red, round, big, and then question mark. Right. So A will be the option.
I had
Okay.
one confusion,
Go
and
ahead.
that was, that in the lectures, Professor Sarkar had said that null is the most specific hypothesis, most specific concept. Okay, so if you apply that logic here, don't you think B becomes the answer because you have got two nulls?
No, more specific concept for this particular example. No, that is your this category yes or no. For that you want. So I think what she meant was she said more specific in general. Any so if I take conjunction of Boolean literals, any without any this category information, what is the most specific concept that you can have? That would be all nulls. That's what it meant.
Okay.
Yeah.
Okay.
Yeah. I hope it's here only, right? Okay. Yeah, I remember that. Yeah, I know. So it'll be yeah, more specific hypothesis. So this is in general what it can be, and then you apply this find us algorithm from there. You say whatever is the most specific. From there, I will start looking at positive training instances and so on. Keep on updating, and until I get some hypothesis which is satisfied by which I can represent using this system. All right.
Okay.
Yeah. Okay. Question number 2. Any thoughts? Should the answer be 48, by the way?
I
I
thought it
felt that
should be
answer was
24.
wrong.
Yes. So answer is
Yes,
24.
sir.
Yeah, answer is 24. So it's already been told to the NPTEL folks. They'll correct it in a few days, right? So why is it 24 though?
Raj, I wanted to know whether instance space means it includes the y variable. So into 2 I felt. 24 into 2.
No. So instance space is only feature space. So if it's not clear, you can go to the week 1 material actually. So I understand that these things will take time to.
So
Yeah.
you remember we had discussed once instance space is feature space plus 1. So that includes the y label. If you include the y label, the instance space here becomes 3 into 2 into 2 into 2 because each label, each point can have 2 plus or minus. So I felt 48 was the correct answer. This is instance space written, a number of instances possible. So I felt it is instance space, not feature space.
So if you see here, this one, right? Instance space X. So set of all possible objects describable by the features. So it's only X, that is your whatever y is equal to f of X, this X. Now,
So,
example, they're saying it's X comma Y. So let me go back to the recording once. I have to remember exactly in what context we discussed that. But otherwise, this is what it is.
number of instances possible in X. X is what? Only the X part, not including Y. That means.
Right. Huh. So by features, that is a feature space that we have basically. That would be your instance space.
I just want to ask one question in as a corollary to what he has asked. See, many a times you use the word concept space. Is this the same thing as instance space?
This is what it says, right? Subsets of objects from X, C is unknown or whatever. So this is the subset of objects from X. So it's a likely a subset of the instance space.
क्योंकि ये बहुत confusing होता है ना, these terminologies, they look like legal terminologies.
Yeah, it can get a bit confusing, but so for now I would say keep this. Let me ask them to like furnish a list of
Can
technologies.
I get a clarification on that? The concept, see what I understood. When we design a model or anything, the entire X space is getting is impossible. So usually we'll get a subset of that X actually. So whenever you're trying a model, you're getting C only. We can't get full X actually. So for that, that's what there's a difference between the X and C.
So a concept space, according to you, is a subset of instance space.
Yeah. Yes, because entire space you can't get it. The entire X is getting is a realistic. It's not realistic basically. So whatever data you are getting for the training the model from the real world, it will be subset of some X.
Okay.
That's
And many times they use the word H capital into, I think, cardinality of H. That H is what, hypothesis space or concept space?
It's the hypothesis space. Capital H you're saying, right?
Yeah, capital H in mod sign, which is, I think, a sign for cardinality.
Right. So this is the cardinality of the hypothesis space, correct?
Yeah. Okay. It's hypothesis
Sir,
space.
sir, what does this mean, sir? If it is mod of H,
Number of elements.
Number of elements.
Size.
Elements in that space, correct? Yes.
but it is always positive only, right, sir? Why does it? They have to take this as mod because hypothesis space, the worst can be 0
No,
or
this
it can be
set
positive.
theory. No, it's set theory. Number of elements.
Set theory, yeah.
It is not absolute value.
Okay.
Cardinality.
Yeah,
No, don't confuse with
okay,
absolute.
okay.
It's a cardinality.
Okay.
Number of elements in the set.
Okay, got it.
Cardinality, not mode operator. It's a cardinality operator.
So in set theory, this is for cardinality. In number theory, generally, this is for absolute value. So hence, I think that's what is the confusion. Yeah.
Okay, got it, sir.
Okay. Yeah. So hence the answer
So
will
here
be
cardinality means it is unique values, right? Unique values of the hypothesis space. Is it?
correct. Unique values.
Okay.
Yes, because you consider H to be a set. A set by default means unique values and the number of elements in that set. That's the cardinality.
Okay.
So just asking Raj, like, so instance space doesn't include Y.
Why? It doesn't.
No, examples include Y, right? So
Example why? Correct.
instances also should be including Y, right? It is the question here. It's little dicey because it asks in number of instance in X part. What does X mean? That is also a question. It is maybe excluding Y, but but if the question asked number of possibilities in instance space, then it would have been, I think so, clearly 48. I think so. If instance space includes Y.
No, but I think we can agree from this material that instance space doesn't include Y. No, it's just the features.
Oh. Why? Instance means an example, right? An instance means example, right? So, it means it should include the label as well, right? Instance means from a real world data we are taking an instance that includes Y.
Yeah, that's what I remember always. Instance, we take it as X plus the category also. I mean
And
the Y label also.
and we discussed this also in the second lecture also, that plus one feature space plus one, if
Right.
it's a one dimensional Y. So if it's
But
then
no, but
your question is not clear because it's saying in X again. X means the X part, that is the feature space basically. I don't
correct.
know this question pay, I don't know, but if the question was number of possibilities in instance space, then it should in that, if that was the question framing, then would 48 be the correct answer?
No. See, instance space as
Mhm.
such means all the all the possibilities with on feature space, all the features what possibilities they have. Now here we are given that you're given the instance space X below. So this is instances. With them, we're also given the examples. I mean the Y values.
So instance doesn't include Y label, you're saying?
Instance space doesn't include Y label. Maybe instance the may it can, I think.
I
I'll have to check this exact terminology here, but at least based on what has been taught, it's instance space is basically just the features, possible number of objects that you can talk about with respect to features only.
okay.
Yeah. Is that okay? Yeah, and then it'll be 24. Why, by the way? Any thoughts why it'll be 24?
3 into 2 into 2, into 2 means all the X labels. How many possibilities,
Right.
categories?
So here color we have three values: shape 2, size 2, and texture 2. So 3 into 2 into 2 into that will be 24. All right. Coming to question number 3 and 4. So suppose we have the instance space X is a set of real numbers R, and H is a be the set of intervals on the real number line, and so of this form A less than X less than B, where A and B may be real constants. So what is the VC dimension of H? And can VC dimension of H be can it be 3? So I think this is again straightforward from the lecture notes itself. So why is it 2? Anyone want to explain?
Basically, that interval clearly divides the say number line, a set of real numbers, into two spaces.
Mm.
That small interval is greater than A and B. So it is, you can say it is an open interval on both sides. So it divides the set of real numbers, because set of real numbers, yeah, also includes frac. Well, if you take a number line, then it clearly classifies it into two parts. So the VC stands is 2.
So is that enough though? I mean, how would you check a VC dimension of any hypothesis space like this? What all steps do you need to think about?
So it means the features, if they are on a real number line, it means it's a one dimensional. So if it's one dimensional, that means it can be only linear. So if they are linear, then a straight line can only divide at the max 2 points. Straight line hypothesis can shatter.
No, but are we talking about straight line hypothesis here?
No,
What
no,
is
it is like if you take 3 points, if we put plus minus plus, we cannot keep the pluses in this format, H format. Correct?
right? So let's say, so if I take 3 points on this line, so why am I taking 3 points on the real number line? Let's think about that first. So what is the idea behind this hypothesis, this VC dimension and everything? Let's say we have uh, uh, when I want to say VC dimension of some hypothesis space is some n, there should be at least one pattern such that these n points, any all possible labelings of these n points, I should be able to classify, right? So now I want to check whether VC dimension of H is 3 or not, right? That means I take any 3 points in any possible pattern, right? Even if in one pattern, if I'm able to shatter them in all possible labelings, then the VC dimension is at least 3, right? So now, but one thing good here is that we are dealing only with one dimensional input. So there's no patterns as such. It's just all in one line, right? And like in 2 dimension, we had multiple patterns. We had to think about how to arrange them and stuff like that. Here, if I have a pattern something like this, right? So where plus minus plus, right? And if I look at, let's say, um, AB, there is no interval in this space which can give me this plus separately and minus separately, right? Is there an interval which can do that for me? No, right? Give me all the pluses, give me all the minuses. So it is not 3. Whereas if I have 2 only, right? So
why is it not 3? Just explain why is it not 3?
see now, so I basically need an interval which is of this form a comma b, which can group all the pluses together to which can group all the pluses together and give me. Can I form an interval like that? No.
No, not possible.
Huh. So what one possibility is, I can have something like this, some union of two intervals, right?
Okay.
Which is like minus infinity to this one and then this one to infinity, etc. But my hypothesis space which I have assumed is only one interval which is a closed sorry, open interval between two values a and b. So I cannot classify such points here, right?
Okay.
Whereas so now but is it greater than or equal to 2? That we need, how will you check? Again, same idea. So take any 2 points here on this space. If I had to, let's say, classify them, if I do the, let's say, classify both of them as plus, or let's say plus minus, minus plus, or minus minus, all of these possibilities I can do using this hypothesis space. Why? So if you see here, for this one, I can have a hypothesis space which does something like this, right? Here I can do it like this, here again like this, and here I can do something on this side or this side, right? Anyway, any side is possible. Any one side you can to choose, right? And I'll be able to classify the points which are given to me in with this negative label also, and all possible labels actually. So hence VC dimension of H is greater than or equal to 2, but strictly less than 3. Therefore, it is equal to 2. Is this clear?
Okay.
Yes, sir.
Yeah. Okay. So hence,
one more thing on this.
Go ahead.
Whenever we come across this VC dimension, what are the concepts? I mean, what are the parameters we should remember? Here, in this case, we see the hypothesis space is nothing but an interval. Sometimes you'll get hypothesis spaces, square, rectangle, whatever. Okay. So in this case, the hypothesis space and one interval is given. That's one source information. Other one is the line. That's the original dimension, whatever. Okay. So like that, no. When we get it, what are the parameters we should remember, or how the calculation goes? You got my question?
See, okay. So if you, so the idea is first of all, you need to understand what is your X space in, right? Your instance space, whatever, right? So in this case, if you were given that they're all points on a real number line, right? So they are just points on a real number, right? Whereas in that example of that rectangle example, which is there in the lecture notes, so there we had two-dimensional points, right? So where we had, like, for example, something like this, right? We have to take two-dimensional points in this two-dimensional space. Then we want to know what kind of hypothesis function it is, right? Hypothesis space it is. Now in our case, it was just close open interval. Here it was, for example, let's say H was some rectangles which are parallel to the axis, right? Then the way you will move forward is something. So let's say you want to find VC of H. You can start with basically saying, let's say I'll start 2 points in the X space, right? 2 points in the X space. So for these 2 points, can I use the hypothesis space to solve for any and all possible labelings, right? Then you will say, I'll go ahead with looking at 3 points, 4 points, and so on. But the story doesn't end here. The idea is in 4 points also. On the X space, it's very simple. There's only one sort of pattern that can exist. Whereas in two-dimensional space, there can be multiple patterns. So even for a single pattern, you should not be able to classify all possible labelings. Only then the VC dimension is less than that number of points. That's how you go about this procedure. Is that clear?
Yeah, it's clear. So it is X space, original space, and then our hypothesis space, and take the number of points. Let's take the 2 points. Then 2 points, all the combinations first. Any one combination you find, in that all the labeling, if it's success, then it's a 2 points. Yes. Again, let's go for 3. Any points you find out, any 3 combination. In that all the labels, any one, but all the labels should clear it. Then you can consider that VC dimension. So we should go with this order of the power X space, and number of points.
Yes, correct.
Yeah.
Yes.
Clear. Yeah, thank
you. So these two things.
Yes.
Okay. Question number 5 and 6. So we have been given 3 classifiers which return plus or minus 1, and tested and their accuracies are as follows, right? So it is 0.6, 0.55, 0.45. Now we have a classifier C, which is a majority vote of these 3 classifiers. So some sort of an ensemble model. Now, assuming the errors of CI are independent, what is the probability that C of X will be correct on a new test example, right? So how would you solve this question? Any thoughts?
See, I've got a wrong answer, but what I did was I did found out the error. That is 1 minus accuracy.
Okay.
And I think the question is that how, and then I multiplied all the 3 because I thought that would be the probability that will be let me just check the question. Yes.
In normal probability sum, you will take all combinations where all 3 are positive, means correct. Then all 3 combinations of 2 correct, and basically independently multiply and sum add those 4 things. Then you will get the answer. Means C1, C2, C3 all are correct, plus one of them is incorrect, other 2 are correct. Like this, there will be 3 conditions. If you add them normal probability wise, then you will get that answer.
Sorry. So
Basically 4 combinations will happen. C1, right. C2, C3 all correct. Then you will find out C1 incorrect, C2, C3 correct, and C1, C3 correct, but C2 incorrect. That is the third case, and fourth case will be first 2 correct and last one incorrect. And then independently take them as independent and multiply the probabilities accordingly, whether it's correct or incorrect, and then sum add all the 4 cases.
Right. So a probability that C of X is accurate, right? It basically means probability that at least two of this classifier C1, C2, C3 are accurate.
Okay.
Right? Because we're talking about majority vote, right? So let's say if two of them are accurate, then automatically C of X will become accurate, at least two of them, right? Because we're talking about majority vote. So now, what is the probability that at least two of them are accurate is nothing but saying this probability. That is probability that all three are accurate, all three are correct, right? Or, right, that is plus any two of them are correct and one is incorrect. Exactly two are correct, that is. So exactly two correct, which means one is incorrect. Now this is saying exactly two correct and one is incorrect, any two, right? So I need to take the summation over all possible such classifiers, which is NC2 in this case, 3C2, right? But choose two of them, each of them at once, right? So that will be the summation that will come here. So what is the probability that all three are correct? That means probability that C1 is correct, C2 is correct, and C3 is correct. So it's some sort of like a sort of
Multiply
event.
three probabilities.
Multiply the probabilities. Why? Because they're independent, right? So probability that C1 is accurate into probability that C2 is accurate into probability that C3 is accurate. Then this will turn out to be, right, probability that C1 is accurate, C2 is accurate, but C3 is not. Right? Plus probability that C1 is accurate, C2 is not accurate, but C3 is accurate. And then same thing here with this one. C1 is not accurate, C2 is accurate, and C3 is accurate. So you can, so now probability of C1 in our case, so I'm writing here in a shorthand, but we're saying that C1 accurate and bar means not accurate. So we know what's the probability of C1 being accurate, that is 0.6, right? So that is, so all of these values will be just plug and play. So now probability of C3 bar will be 1 minus 0.45 because you want to know what is the probability that C3 is not accurate. That's it. So you can plug all these values here, you will get the answer 0.55 something 05. Right?
This equation which you have written is basically because of the majority vote.
Yes.
Therefore,
correct.
you are saying that the majority vote would be that everybody's right or at least two are right. That is the logic.
Exactly. Yes. So this
Okay,
is the
understood.
leap.
Okay, understood.
Okay. Any other doubts here? Okay. Sixth question. ADA boost on a training set of 3 boosting iterations, and then you.
Yeah, I have one small question on the previous one.
Go ahead.
In this case, it is say okay. My question is, when you are telling the majority, is majority limited to the number of the classifier majority or their probability majority? Can you get the some situation where the numbers are as per number it is a majority, but I submit their probability is not majority? You got my question?
No, actually. What probability is not majority?
So
No,
he's
here is
doing
there,
the
no,
probability
their
addition.
accuracy 0.6, 0.5, 0.4. Okay.
Right.
Case if I take the two cases, of course it will be the more. Okay. Now is it cases will come somewhere for me. The one is 0.6. One is 0. See, the sum is not one basically. Okay. If you see the accuracy, they are independent accuracy basically.
Correct.
Okay. Now think about one more is there, class C3 4 is there. That is actually, if you imagine somewhere, see, it's a year 654 is given. Assume that one is 8 or something high majority, and other one is very 2 only. Okay. So even though the other two I submit, if other one I submit is not reaching the other, so majority is the number majority I'll take always, or I'll take the probability majority, accuracy majority.
Huh,
Okay.
question. I got your point. So yeah, so majority vote by default means just the number majority. So what you'll do is you will say C of X, whatever test example you have, you'll pass through all the classifiers, you will see what each classifier is giving you, and then take the majority among them. That will be my final output from this ensemble, so called, right? But you also have this weighted this one, right? Voting. That is what you're saying, if I'm not wrong. So if I'm not wrong, there is something, I guess, later on you get, right? Weighted voting, right? Based on accuracy, right? That is that is where you're coming from, if I'm not wrong. So unweighted voting is what we say. When you say majority vote, that's what that's the basic one that exists.
Okay. So voting is there based on the weighted and unweighted. In unweighted, just you will take the number of majority only. You will not consider the accuracy. But when come to weightage, we will consider accuracy and multiply that. Okay. So there are two different approach. Okay.
Yes.
Okay. Clear. Thank you.
Sir.
Go ahead.
Sir, if we take the C4 one, then how will we solve this? Like we will take all probability of all correct plus probability of 3 correct and 1 incorrect. If C4 is also considered.
So if you have C4 also, so hence in these cases we don't take even number of classifiers, because we at least want some majority, right? So because let's say if two of them say something else and two of them say say the opposite, then you don't have an answer actually with you. So then what we do is we generally take a odd number of this one, and in case you have an even number, then you have to decide what majority means, because in the case of equal opposite this one. So then you will decide, like, okay, we will consider that case as, let's say, unclear, right? And so in that case, we will say, okay, majority means more than half compulsory. So then you will say probability of all 4 correct and plus probability of any 3 correct.
Yes, sir.
Right. Okay, so that's one approach. Or we can also have one approach saying that, okay, whenever, let's say, two are let's say saying positive class, let's say C1 and C2 are saying positive class as the output, but C3 and C4 are saying negative class, right? So I will say, okay, in such cases, I will always take the answer as positive class, right? So like some sort of bias towards positive. So if that's the case, then you have to actually break this down further. You will say, okay, in case 2 are correct, but is the right answer positive or not? So then that condition will come into play when you're finding the probability of ensemble being correct.
Yes.
Okay. All right. Yeah. So 6th question, ADA boost, and then you have these coefficients and 3 classifiers and their results. So I hope this is straightforward. Some just, I guess, I've weighted some of these classifiers, right? So what you will get the answer is?
The answer is 1.
1,
alpha,
right?
Alpha into hx1,
Alpha
plus the other 2. So you get the answer as 1.
Right. So hi of x, I guess, is what you'll get. You'll get this. You'll get some number, I think 0.1, if I'm not wrong. So because it's more than 0, you will say it's output is 1. Okay. Bagging is done to
decrease variance.
Decrease variance, right? So we have some. So let's say we have like neural networks or KNN sort of algorithms which have high variance. So then you use bagging to decrease the variance of the overall architecture that you have, ensemble that you have. Then weak learners are the ones used in boosting algorithms. They're called weak learners.
Weak learners are learners whose accuracy is slightly higher than 0.5, isn't it?
Right. Slightly higher than 0.5. That is error
rate slightly less than. But actually,
Correct.
This question is very badly framed. It should be, the word should be slightly higher. Error rate
Correct.
less than 0.5 could be 0.05, and that can't be a weak learner.
Weak learner, exactly. Yeah. So the phrasing is a bit off, but again, I mean, among these 3 options, B seems the most right among the options that we have, right? So no error would be a very strong learner. So weak learners would be less than 0.5.
See, many a times we find, now these questions which are marked wrongly, it happened, this is the third or fourth time it has happened. Today it happened in that 24 or 12. If this happens in the exam, then there is no other way, no way for us to even raise our voice, because this should not happen.
Is it so? I thought there is some sort of a like rebuttal or something, like recorrection or something. Is it
So
not?
we don't get the answers. We don't get the answers. We just get the scores.
Oh, is it? Oh.
Yeah.
I can say something here.
Yeah.
Go ahead.
Right. Well, good afternoon, everyone. In the exam, in the previous NPTEL courses that I've seen, the interface, it has one facility where you can mark a question for review, which means you're really flagging that there might be an error in the question and that would need to be looked into. And I don't know what happens whether after you mark it, but there is a facility to mark it. So if the question is wrong, I suppose you can just mark it for review and then give your best answer. And it gives you a message over there saying that questions marked for review, your answers will be considered based on whatever you answered after the question has been reviewed or something like that. That language is there. What actually happens because of it, because of marking for review, that is not transparent to us. Secondly, we don't know how many marks we got for individual questions, but we just know the final score that we got for the end semester. That is the in-person exam. So we don't know about individual questions, like have we got the marks for this question or what, did the marking for review make a difference or not? That's what I've seen so far.
I thought marking for review means in the process of examination, you don't want to answer that question right away. You want to mark it later, yes, so you can come back and review.
Right,
that is what I
right.
thought.
Yeah.
We
yeah,
use
even
it like
I have
that.
attended. Yeah, even I have attended
go.
several other non-NPTEL also. Mark for review is for us for reviewing. So might be in case we are not confirmed at that point of time, we don't want to spend more time. So we can mark it for review so that we can come back and we can revisit that question before we submit the paper. So that is what is marked for review is.
That's what even I use it for, and that's the only facility we have for using for performing this function. But my understanding was that they provide this to us so that we can mark out the questions which might have errors in it. That's how I understood, but I'm wrong.
So, so we can, I mean, I would suggest, so post the exam, if you have any, questions which are sort of dicey, put it in the discussion forum, and we can, ask the course TS to have a look at it. Like that, that's the max I guess we can do in case it happens in the exam for some reason. Right.
Right. And regarding that, in fact, there's one more concern. Typically, what I've seen in previous NPTEL courses is that the exam is conducted on the same date in the morning and afternoon sessions, and people posting questions, doubts, literally contents, and what has been asked and what is the problem with it, etc. from the morning exam, and people before the afternoon exam can see it.
But how can they do it?
So,
you're not even allowed their mobile inside.
No, of course, but you come out and type it out. No, people come out and type the entire question.
But that will be hard. There are about after 70 questions, you may be able to remember 2-3, not more.
True, but you'll do it for the problematic questions. So, well, it happens. I mean, I've seen it happen. That's why I'm saying this in previous courses.
So but the point is like it's the same paper that goes in the morning and afternoon session.
No. There are different papers. It's always different papers.
So then what's the problem?
The problem is that you get the distribution of topics. That is whatever modules or weeks 1 to 8, which questions are asked more, which was asked less. Were they asked from just this year's assignments? Were they asked from the last 3 years' assignments? Things like that. All of that information is coming out. This is actually a loophole in the NPTEL's examination system, and I have no idea how it can be fixed, but it happens. And I mean, the reason I've flagged this right now is because when it is recommended that you come out and then post it, I would say post it after the day is over.
Yeah. So please do that. So we can post the day. I guess that's one to make sure that.
Can I give some answer from this for this question?
Sure, go ahead, Satish.
Yeah. Just I'm just telling my opinion. So in general, no, any like national level exams, no, it is impossible to conduct in the same slot in general. Okay, like you see JEE main, JEE advanced. Okay, so there will be 2 slots. Okay, so usually the exam agencies will never follow the pattern. It will be randomly selected. Okay, So what the sir told, actually it's coming the same pattern. I don't think it will come same pattern actually. Like he was telling the weightage of the module 1 is more, that way it is communicated after coming out of the exam. So I don't think they will make the same pattern. And if that's not the same pattern, it is no benefit of morning or after lunch. Okay, because I many times we seen that the morning is very tough, evening will be afternoon is very easy, will be there. So there's no correlation. Randomly they selected actually, and up to the individual to select the morning session or afternoon session. Okay, if you select afternoon, that day it can be maybe very more complicated may come. Okay, so I don't think it is. If it is same pattern is coming, you can, of course you can inform. Okay, that was the my understanding of the problem.
Have you guys received your admit cards?
No. Only center and time slot.
Yes, yeah.
Okay, how many hours of exam? Hello? It will be 1 or 3 hours. What will be the hour duration of exam? Actually, I am appearing first time, so.
Yeah, even I am appearing first time. So, what will be that pattern, like the exam?
And Python coding will also.
The NPTEL folks for this. I'm not aware of these details actually.
I can comment on that. I have taken courses in previous 2 terms. The NPTEL, firstly, the slot always standardized. What they declare is 9 to 12. What actually happens is that for every individual subject, the individual instructors, because like for say humanities courses or paper-based exams, some can be 1.5 hours, some can be 2 hours. Whether this, but every single exam that I have taken so far has been the full 3-hour exam. And the interface
that's
over
a 12-week course. 12-week course.
No, doesn't make any difference. I've taken so far 4 8-week courses, and all of them were 3-hour exams.
Okay.
So,
all are objective or
everything is objective, MSQ or MCQ only. Or the third thing that you can have over there is that they fill in the field, as in type in text. You can just alphanumeric characters, no special characters, a field over there. And hopefully, I mean, if the question paper has been set properly, they will tell you what formatting to use, as in put a space, don't put a space, don't leave a trailing white space, things like that, because it's all machine assessed. So those instructions should be there. But if that is not there, then the answer will actually be correct, but it will be marked wrong. So you can have one of those things. There is no, typically there's no typing. You are provided an on-screen calculator. You will get the link of that at some point in time. And as in like for practice, so that you get used to the interface. And you do not have a Python compiler over there. You do not have, I mean, I've taken several programming courses. You never have any kind of compiler over there. You do not have access to any kind of debugging tools or sort of system information over there. You're going there only with your knowledge, and you're selecting ABCD, or you are typing a number or a letter.
Okay. Now for this course, actually Python relevant also could be asked, or it is just a subjective and based on machine learning only?
Again, no idea. So I see. I would suggest these final exam questions. Whatever doubts you have, please push in the forum. I am not the right person. I don't know all
actually
of these.
Somebody posted, but we didn't receive answer from now. Many days we are waiting. Like
okay.
Already somebody have posted Python relevant.
I'm sorry.
Already there is one post regarding it.
This
Will
one?
in exam if Python will come or not? Python programming, all this programming exercise. Actually, they have used.
Okay, sure. So I can do one thing. I can make it more visible to the course TAs. Let me do that. So they'll be able to help you out with that. Is that fine?
Okay. Thank you.
Sir, this question is this question is more relevant because in the assignments, whatever assignments we have, 8 assignments, there never any Python questions are not asked actually. If suppose the Python questions are there, you can expect 1% or 2%. Since
like
there is no Python questions are there in the assignment, and suddenly it comes, it may people. That's the reason again there everybody is asking same question again and again.
Right. So let me do one thing. Let me just start up on this one, queries regarding final exam, right? So you can just post all your questions here. Okay, so I'll just ask the course TAs to look at this one, right? And then you can, what all questions ever you have, you can just post it here. Does that help?
I had 2 more things to say.
Please go ahead.
Yeah, right. So about the paper pattern and morning and afternoon thing, the previous comment from one of the others, I have actually seen courses among the ones that are taken where the paper pattern has been repeated and and it has been consistent and it has been repeated over semesters and years, and it was known before the exam, before the course started, that this is how this instructor runs this course. So it's whereas there have been, in fact, the best course that I've seen is where everything is unpredictable and everything is of equal difficulty. And distribution across the topics typically, or at least difficulty levels across topics, in some way needs to be correlated from slot to slot, because otherwise the marks scored in the respective different papers are not going to be comparable. So that, I think, is a constraint that the paper setter is operating under. But this is again observation from the few courses that I have taken. I don't know how, whether, I mean, what this next one is going to be like. That, of course, we can never say. So
okay, question
that
9.
was
Right. So I would suggest again, what all concerns you have regarding the final exam patterns, difficulties, whatever, just put it there, and they'll try the best to be able to solve for whatever issues we have. Does that help?
Yes, and I have a question regarding question 6. The text before question 5 says that the following data is for questions 5 and 6, but the accuracies of C1, C2, C3 provided over there were not required in the calculations for question 6.
Okay.
I mean, to my knowledge.
All right. So I mean, yeah, maybe not required. Yeah.
Yes,
I guess. Yeah. It's not required. So. Okay.
So that actually got very confusing, because I was wondering whether I was doing something wrong.
Right. Yeah. I guess this is something that we can frame the question better. I guess. Yeah. It doesn't really make sense to have that for this question also. All right. Anything else?
Yeah. So for question 8, like we usually use weak learners as something greater than 0.5, right? Little more than 0.5. Or
no. So weak learners.
No,
Error
sorry,
rate
that is accuracy. So that is accuracy. Okay.
Correct.
Error rate is less than 0.5. Okay. Accuracy will be something more than 0.5, but not too high, right? Those are weak learners.
Yes, that's the idea. Yes, not too high. Correct. Weak learners. Yeah. All right. Okay. Dropout is a technique in neural networks where many different models are trained on different subsets of data. In ensemble learning, dropout techniques would be similar to bagging. I hope all this is fine.
Yeah. Only I just want to ask whether dropout was explained in neural networks class. I'm forgetting. Was it?
I don't think it was. I don't think it was mentioned there. But
so we don't know what is dropout.
Yeah, even I couldn't understand this question, sir. Like, I don't know how bagging was related to this dropout, even because I wasn't familiar of this dropout.
No. See,
neural network.
No. But that's the point. That's the point of this question. You don't need to know dropout. What the point here is, they're saying dropout is a technique where many different models are trained on different subsets of data. So you have different. So the idea you need to take from here is you have different models. They're being trained on different subsets of data. So then in ensemble learning, what would this be similar to? That's exactly what bagging is, right? So where you take subsets of keep training different models and
but it is not different model, right, sir? In bagging, it is same model trained on different sets of data. At least that is what I understand. It is a kind of similar models, but it trained on different sets of data, and then you get that majority voting output.
So similar model, different data means different models you will get, no, at the end of the day.
So by model, we mean either linear regression or decision tree or a neural network. So in bagging, if you use decision tree, then you're going to use decision tree all throughout for the same sets of data, for different sets of data.
Correct.
Yeah, but that is not the case when in boosting.
So okay, yeah. So boosting may be different, but the idea in bagging is this only, right? So where you have a similar sort of algorithm, I would say. Like for example, let's say decision tree. You will train that same decision tree on different subsets of data, and then you'll use some sort of a voting mechanism to combine the output. That's exactly what this sentence is supposed to give you the hint about.
Okay, so when different model means it is like the same algorithm, but when trained in different set of data, it will be a new model which is constructed. So that is what it means. Okay.
Yes. A model means let's say a given algorithm plus the data, whatever it has been trained on.
Okay.
Can you just clarify actually? Okay. I remember the bagging. Okay, different subset of data we'll take it that with replacement, whatever randomness, and in the bagging case we'll give the weightage where misclassification happened. Okay, but both the case different subset data. How it is different? I am not understood. How I am telling is bagging or boosting. What is the, because both the place I will take different set of subset of data only, no?
No. In boosting, the idea is you will change the distribution of the data that you will train the algorithm on, right? Isn't that the idea in boosting?
No, boosting actually that I remember the different basically in the bagging. I will take the one set of data. I will train the model. Now again I'll say take the same big set. Again I'll do the one more. That is with replacement. That idea is called with replacement. That means I will take once again data randomly. Okay. So some 4 times, if I have the 4 models I want to train it, 4 times I'll take random. Okay. But there is no condition. Next time when I'm taking, I may take the same data or different data. Okay, that's called with replacement. Whereas in the boosting, what will happen? In the first time when I take, then I have done the misclassification. Whatever data set I done the misclass, I'll give them more weightage actually. Okay.
Yes. So that's boosting. Correct.
Correct. Now in this question, the question is telling I am working on different subset of the data.
Right.
Different subset data. So different model, I don't have any question, because the different models, it can be same model, different algorithm, or it may enter different model, because ensemble don't focus on which model you're doing. It can be different model, it can be the same model, different algorithm, it's okay. But how the data sets, how the data you're taking in the boosting one methodology and in bagging different methodology. Okay. That's only different. So how this question I can tell confident it is a bagging approach or it's a boosting approach?
No, but Satish, see here the point is we were training on different subsets of data, no? So in boosting, the idea is you have the whole set, you have the complete data set that you want to train on. You will change the distribution, basically the weightage that you give for each data point. In bagging, the idea is when you're taking one subset, the next model that you build can have a different subset altogether.
Okay, I'm not very convinced, because the problem. Okay, I understood what you're telling. See what I can do another way. In the boost bagging, I am giving the same equal probability for all the data set. Basically, the idea is actually all the data set is the same probability I'll give. Then I'll randomly pick up.
Correct.
Whereas in the boosting, what happened? Once I take some data set, the full data set equal probability. I'll take some random. Next time when I don't do random, I have the weightage now, because I have the misclassification. So I have to do one step extra here. Basically, what I'm doing, once I got the model ready, I will see the model apply for entire data, and I see that how many misclassification happened. So it's a 2-step activity basically. Train the model, then subset data. Then after training, apply that model to the entire data set. If there's a misclassification, understood that misclassification and do the weightage. So there's some 2-phase activities are there. Okay, but that is the internal activity. How it is matters.
In boosting, see, in boosting, you're not doing a subset. Why would you do subset in boosting?
See, initial how much data I will take. I have.
Let's say you have okay, so there is the algorithm that's open here on the screen, right? So let's say you have m data points, right?
Okay.
You will use m data points, and then you initialize them having the same probability 1 by m or whatever, right?
Okay, so every time, okay, clear, sir. So we okay, I understood your point. First time I will do the full set basically, correct? Next time I will not take full set. Basically, based on probability I will take, correct?
Some probability you have to choose, right? Because you're saying that it's some distribution that you will.
Okay. First iteration we are taking complete set actually. First phase actually. The second phase I will not take complete set. I will take I think I remember what they're telling. I'll not take complete set first time also. First time also I'm taking subset only, but randomly I'll take because equal probability. I think someone can correct if I'm going wrong. Who are attend the class?
See, Satish, you will take each time full set, but the probability of choosing a point will vary each time. First time you will choose with equal probability each point. Second time for boosting case you will not take.
No. That's what I'm telling. When I'm telling equal probability, you're not taking the full set. You're not trying the full data set. No. In that, see, since it's equal probability, suppose you have 100 data set. Okay. Now I want to take the 30 only. I don't think in the boosting also I'm trying with the 100. I will try with the 30, but probability is equal for all 30, 100. Am I right?
Sir, I think in boosting the training is sequential, right, sir? Like we pass the whole 100 data points to the first model. So whatever points have been misclassified, more weightage will be given to that and passed to the next model. So the training happens in a sequential way, whereas in bagging it happens in a parallel way.
In bagging,
subsets of data. Yes.
Subset or in different this one, and then learn a model parallelly on this one. You're right. So in ADA boost, what will happen is you will then choose m points again, but with this distribution.
So I think what Satish's question is, sir, like let's imagine if there is like around 1,000 set of data, and in that 1,000 we might select 100 for each sampling. So in bagging, we'll select 100 and parallelly we might run 5 models, 100 of each, and we will do sampling with replacement. So in boosting, his question is it since it is sequential, is it we send all 1,000 for every, like, do we send all 1,000 with equal probability, or do we sample only 100 and then give that equal probability to those 100 only?
No.
We send all the data points at a time.
You can use all, no? What's the problem in boosting at least?
Sorry, sir, I couldn't hear you.
No. So my point is, you can use all the 100, no? So
all
wait
100, right? Okay.
So actually, and
that means you don't need you don't choose a subset in boosting.
Exactly. Yeah. So we don't choose a subset. We give only probability.
No.
You use a subset to train, and on full set you will do the prediction.
1,000.
You will take subset set 100, train it. That's what ma'am was trying to say. We will take out of 10 some subset, train it, and then use that model to get the output for all the entire set. And then now while training the second model, you will use, because you have got the correct and wrongs for the entire subset, entire say 1,000, and our sample size is say 400. So you will choose 400 from the entire 1,000 set with the new probabilities. Okay.
With this distribution.
So
in that case, it means
while training we use 400, but there is another step like validation step, which means uses that model to get the output for all the entire 1,000 and
weight calculation or weight calculation.
I think so. It's clear. That's what I understood from ma'am.
Yeah, correct. What he told correct. That's why. So I think the phase 2 is extra in the boosting. Maybe in the dropping that is not there. So it's very close to the bagging. Maybe correct.
Right.
Yeah. So sir, I understood now. So second phase was there. No, that's why the second phase where we again classify all the inputs, basically m data sets, so that now we give the weightage. That process is not there in the dropping also. Maybe. So that's the reason dropping is very close to the bagging.
Dropout. Yeah, correct.
Yeah, subset is there. Both the place subset is there, but there's one extra work is there in the boosting, because you have to again give the weightage. For the weightage, you have to check the validation. That is extra process basically. Yeah, and that is not there in the dropping. That's the reason it's very close to bagging. Understood now.
Sir, I couldn't understand, sir. Might be anybody can repeat that.
Can I explain, sir? Can I explain now?
Okay, one second. So what's not clear, Bhavani, to you? What is not clear?
So the So again, like might be the same question what Satish sir asked, sir. It is like, for me, both are taking a subset. Even boosting is also taking, I ignore probability, sir. It is same probability or more probability, but still it is taking subset. So out of
Correct.
1000, it is taking 400 points. So
Fine.
both are bagging and boosting, both are considering the subsets and training on models. So
Yeah.
how is it that dropout is similar to bagging and not boosting? So that is not
right, because
it's
so
not clear.
in bagging, the point is in the next, for example, let's say, so if
The
we don't doing in parallel, the idea is the first model that you would train, you will choose any 400 from here. Second model also, you will choose any 400, any subset. It doesn't matter.
Right.
So there is no probabilistic choosing anymore. Whereas here there is some sort of an intelligent approach where you say, okay, choose those where I've done more sort of error.
Okay, but yeah, but they are not asking about if it is probability or weightage choosing or not. The question was just about different models are trained on different subsets of data. How are they weighted, not weighted is not given. So, but in that case, both. Yeah.
Can I answer that one?
Sure.
Yeah. See here, before taking the next iteration, I should randomly select a subset. Am I right? For that, one extra activity is there. What is that? The model you should apply for entire data set. Then you'll get how many misclassification happened, correct? Then there's a weightage. So there's extra work, am I right? Extra iteration, basically. Understood? That will be not there in the dropout. Got the idea?
Model has to be applied for entire data set. Why
yes.
should it be applied?
Yeah. Sir, can you open the sheet, sir? That sheet.
See, see, Bhavani, when you want to choose the next set of 400 from these 1000, right? So how will you get the probabilities of these 1000 elements? What probability of choosing each one should be? That you will get only because you run the model on these all 1000. You will get to know, okay, for this particular sample, was I correct or not correct? And then using this, you will now say, okay, take more of these misclassified examples.
Okay, so what we're saying is step one is only while building the model, we take only 400. We take a subset and we build the model. And then for that model, we run with all the examples at that stage and then get the output and then create those weights and then repeat this step one and step two for every stage. Next stage again after you get that weightage. So we will again run that.
Yeah,
okay,
right.
Okay.
First iteration boost and bagging same, but second iteration not.
All right.
Okay. Got it.
Yeah.
Thanks.
Okay. Then yeah, so which of the following option either are correct regarding the benefits of ensemble model? Very clearly, better interpretability is not a strong suit of ensemble models, right? So directly you can remove A, B, and D. The answer is C, right? And it is more generalized model because you're able to capture more number of patterns from the data. And because you're looking at subsets of data, or in the case of boosting, you're giving more importance to wrongly classified data. So you will be sort of more tuned towards the trying to know what's the actual pattern than fitting to the noise, and better performance in the sense of because you're let's say in the example before where you had like multiple classifiers. So if you have weak learners, you can actually use multiple of them to get a better performance, better accuracy, or better error rate. Is that clear? So that should be your option C.
Could you just explain slightly in a very short way, what is this interpretability?
Okay, so interpretability basically, so let's say you learned some pattern, right? So your ML model learned some pattern to classify data, or to do your continuous regression. So the idea is, what is that pattern that the model has learned? So can we understand what pattern it was in terms of something which is humanly understandable? So that is a problem in ML, in complex ML algorithms, and especially in case of ensembles, because then there you have multiple ML models which are running together. So therefore, you need to understand each of them separately, and then how they're combining their outputs and etc. All of that will become a complex process. Is that clear?
So interpretability means you don't understand how are you getting that pattern.
Yes.
You are getting that pattern at 30,000 feet above sea level, and you're able to see the pattern, but not at the microscopic level.
Correct. Yes.
Okay.
Right. So what is
it similar to like with finding reasoning why that model is selected by ML? Like going back, like in CNN image processing, we generally look back what is actually learning, what properties. Is it the same or that's different?
Yes. So in that spirit itself. So basically, we want to know what the model ML model has learned through these patterns, through these data points that it saw.
Can I say something here?
Go ahead, SK.
Right. I mean, on this point, there actually, I think, was something in the lecture slides illustrated with respect to the real number line, the one-dimensional data, 3 data points, and the VC dimension, etc. All of that. When you have a minus in between 2 pluses, then you cannot capture it using intervals. So after the ensemble exam, after all the ADA boost and all of that example, what was shown was that the final set of all classifiers that you have, what it's actually capturing is that union of disjoint intervals, so that the 2 pluses on the outside are one set and the one in the middle is not. And this could be created only because of this entire process of using ADA boost, etc., and not otherwise. And in the general case, like if you are dealing with an n-dimensional space and instance space, and then you are defining some simple to define thing like these contiguous intervals, then the final result after doing the ensemble method would give you a very complex subset of that entire R n-dimensional space, which would probably have no physical meaning to you, but it would give you correct answers.
Okay.
That is the way it would lack interpretability.
Right. So
that's how I understand.
RN space, what is what the model has learned, basically what conjunctions of intervals it has learned for the particular example. But can you so though it is right, but what has it learned? Can we explain that in terms of some physical significance or some human understandable form? That is interpretability.
So in short, the output is a black box.
Yes. So your ML model is now a black box. You don't know what it has done, though it is working perfectly.
Okay.
Though it's right.
Okay.
Yeah.
Sir, one question about about that last point, bagging and boosting. I was rethinking on whatever you were mentioning. So in like we had the 2 steps, right, sir? In boosting, step 1 is we take those 400 samples and we train, and step 2 is we validate across that all 1,000 samples. Right. So in bagging, I think step 2 will not be there, right, sir? In bagging only we will have 400 samples and then it will train, and each model will train across different 400 samples and it will take the majority. Might be some samples would have not been selected in any of those models.
Yes, correct.
Is that right? Okay. So only step 1 in the bagging.
Yes. Only step 1.
Oh, okay. Thank you, sir. It's clear now.
Sir, what she just said, like 400 we take for training and then we validate the 1,000. So sir, how will change the probability? Like the weights, how will we focus to increase the weights of the misclassification?
So isn't that done here though? So your each of the weights is now then you change that with this formula, right?
No, sir, I just got confused. The second step we'll take another 400 from that. So I got confused in the step 2.
Yeah. Which boosting or bagging I talk about?
Boosting, sir.
Boosting, yes. So after your so in this step 1 there are 2 things. One is you first choose some model, right, with equal probability of let's say 1 by 1,000 in this case. Once you have trained the model, you will run that model on all these 1,000. So now you have some, let's say, some classification error happening here, right? Then for each of these 1,000, which for example, let's say you can now have a different probability distribution. Previously, it was exactly 1 by 1/1000 for each of them. Now it is different. So now you will choose a 400 based upon the probability distribution. That is, whichever has the higher probability value, it will get it will have a higher probability of being chosen in this 400 subset.
Yes.
And you will change that probability using this update rule.
Yes.
Clear? Is that clear?
Yes, sir.
Okay. All right. Question 11. Any questions here? B and D seem straightforward. Any thoughts on this question?
B was a little dicey to me.
So in each stage, we train a classifier which makes accurate predictions on a subset of the data points, where the subset contains more of the data points which were misclassified in the earlier stages. That's exactly what we have here, right?
Which contains more data points which were misclassified.
Yeah. Correct. Because
you could have less data points which are misclassified.
Sorry?
You could have less data points which were misclassified.
No. But the point is, you will change the distribution in such a way, right? So that you have more number of misclassified points, because you want to correct on those points also.
Like suppose you have got 10 samples, out of which, and to start with, all have the same probability. You run the algorithm, and then you find that 2 have a very small probability. Therefore, you want to boost them, and therefore you change the what do you do? Next time when you run, you did not have more.
No. Again, so let's say you have 10 points, as you said, and let's say in 2 of these points you actually didn't perform well in the first scenario, right? In the first step. So now what you will do, you will say for these 2 points you will have higher probability. Give them higher probability of choosing, right? Because in the next step you want to again choose some subset of like this 10 subset, whatever you have, right?
Okay.
See, the idea is you want to give higher probability of choosing 2 points. That's the boosting algorithm. Now you would want to give higher probability to misclassified examples, because there your model is not able to perform well, no. So therefore, so that means there were some patterns which the model could not pick up. So ideally, looking at those misclassified examples, you will be able to do better going forward.
Okay.
Right. So it's like, for example, in when you're learning some exam or giving some exam, right? So in case in the first unit test you did some mistake in some concept, so for the final exam you will learn that concept more, no, because you did some mistake there. That's the idea. Okay. Question 12. This should be straightforward from the sample complexity using the VC dimension example, VC dimension formula, right? Any doubts here? So if you remember, we have some formula regarding the sample complexity with some factors, everything, and then we have some VC of H here, right? So if VC of H increases, the number of samples that you will require will also increase. Rahul, if you're not speaking, can you mute yourself? All right, then question number 13. Again, this also should be straightforward from the pack learning model, sample complexity. Right? Any thoughts here?
I have a question here.
Go ahead.
I have a question here on question 13. Supposing 400 had been one of the 4 options, then what would the correct answer have been?
Sorry,
what happened?
If 400 had been one of these options, there is 1, 2, 20, and 200 as the 4 options. If 400 had been one of the options, then what would the correct answer have been?
Why would
it is proportional to 1 upon epsilon or 1 upon epsilon square? That's the question.
Yes, it does not state whether it is a finite or sorry, consistent or inconsistent finite hypothesis space. The only correct answer is 20 because that corresponds to finite consistent.
Finite this one,
but finite inconsistent corresponds to 400.
All right. Take it. Let me get. Probably then we'll have to give this as a grace because then if it's not clear, then it doesn't make sense.
Actually, there's only one correct answer. So it's not a, sorry.
That's a good point. Because if inconsistent place, the number of points are proportional to 1 upon epsilon square.
Right, epsilon squared. So, but nothing which talks about this one, is it?
Okay, could you just give me an example of, I understood the mathematics, but could you give me an example of an infinite hypothesis space? Means what? Infinite hypothesis space, linear regression is an infinite hypothesis space.
This question, there is no direct in the slides. I don't think anywhere it is there. So I think better you explain also. I found the answer, but again it is like mathematical thing. Slides may direct. I don't think the relation in slides not there.
So what relation are you?
No. How it is calculated that 20 times? How it came? The PSC that.
So this one, right? For the consistent case, if you look at it, you have 1 by epsilon, no? So m is proportional to 1 by epsilon. So let's say if epsilon becomes so it's going from 0.2 to 0.01. That means it's reducing by 20 times. Therefore, m will increase by 20 times.
Okay, that ratio. Okay. Clear.
That's the point. Right, because we don't know. The question doesn't say about inconsistent, where it is epsilon squared. So that will be a problem. Fine. So. Hello. Hello.
Hello.
Yeah. 1 second. Just give me a moment. There's some issue with my laptop. Just a moment. Okay. Can you guys hear me?
Yeah, we can hear. We can't see.
Yeah. Just give me a moment. Where are we? Yeah. Can you guys see now and see the screen also?
Yeah.
Okay, great. Fine. We were discussing what? By the way. Yeah. So you wanted an example of finite hypothesis space, right? So
yeah.
That's been example is been given here, right? In this case, for example, let's say if you have conjunction of n Boolean literals, and if h is, for example, let's say 3 power n, right? Because we have only n Boolean literals, so basically each value can either occur in the positive form, negative form, or or cannot occur. So therefore, the number of possible hypotheses that you can have is only 3 power n for n Boolean literals. So that's an example of finite hypothesis space.
And infinite, we know infinite, a simple linear regression infinite. Okay, now in this, the meaning of the word this consistent hypothesis means that C and H are the same. Am I right?
C and H, no. So the error on the training data is 0. You don't have any error on the training data.
So here when you're saying that in that consistent case in the slides which he has given, where m is greater than or equal to 1 upon epsilon, that is when the training data is 0.
Yeah. So when you have 0 error on the training data, that's correct.
Okay.
Yeah.
So at that time, that is the number of samples is proportional to 1 upon the error rate.
1 upon the error rate, yes.
And in inconsistent case is a case where there is significant error. I mean that the error. Okay, consistent case is when you said that the error on the training data is 0.
Is 0, yes.
Then what is this eta? That is an error, isn't it?
The epsilon. So no. See, the epsilon is basically the error on the whole data set, like the actual data set that we have. So even validation, for example, test data, all of that.
Okay. So you can say epsilon is a generalization error.
Yes, correct. So we're saying we want the error on the overall data set to be bounded by some value. So this is what it is. Error on the whole data set, that is D of whatever hypothesis space that you find, should be bounded by some epsilon.
And D does not include training data because training data is 0.
No. So you would include training data. I'm a bit unclear actually here. I would have to check that. But actually, ideally you could, because the idea is that you're doing well there. I mean, it is a part of the training the observed distribution of examples. So I guess you could include, but I'll have to check the exact thing here. Yeah.
Okay, and just a simple thing. Many times we get confused. Now, in this inconsistent case, you have a number of example proportional to 1 upon epsilon 0, epsilon square. Or so it means that inconsistent means there is an error on training data.
Yes.
Okay, and what is this delta then? Delta is what? What exactly is this delta? Which many times we get confused between E and delta. I mean epsilon and delta.
We had a discussion last time.
Yes. It means that the probability of the error. That's what you're saying.
Yes. So if I'm not wrong, it was something like this, right? So this is, I guess, something like this, right? So you're saying that what is the probability that you will find such a hypothesis? I want, let's say, such hypothesis spaces such that the probability of finding such a hypothesis itself is greater than 1 minus delta.
Okay. And just last question, in this inconsistent case.
Sir, 1 minute. Even though when I'm saying it's not giving the clarification what is the delta, because see 1 minus delta, but what is the meaning of the delta? Okay, of course, telling that it's less than 1. And I'm writing that 1 minus delta, it is ensuring that probability value is less than or equal to 1. But what is the meaning of the delta? How delta is derived, or what's significant of delta?
So if you remember, we had discussed this idea. The XOR example. So let's say this, no. So let's say I choose the hypothesis space to be linear lines. I mean, right? So straight lines, right? So now, what is the probability that I will find a linear separator which can classify this problem with some error rate, let's say 10% error rate? What is the probability?
Okay.
No. Tell me what's the probability.
I'm not very clear of the question. What is the question here? I'm not very clear of the question.
what is the probability that I will find a H which is 10%, sorry, 90% accurate for solving such a problem in among the linear lines. So what is the probability that this will be true? Can you tell me?
0%.
0.
Yeah.
Right, because no linear line can solve this. So the idea is, if you cannot find something like this, that means you need something more complex. So here the probability that you will be able to solve such a problem using this linear hypothesis space is 0. So another question, for example, let's say H is, for example, let's say some quadratic approximation or something, right? So then you will ask, okay, same thing. What is the probability that I will find a H which is 90% accurate in this hypothesis space with some probability? Now, so basically, I would only entertain such hypothesis functions if and only if they have a probability. I have the probability of finding such a H which is more than 1 minus delta. Does that make sense?
Yeah. Yeah, it makes sense. We have to revise it over and over again. We forget very soon.
No, what is my I'm saying? Suppose I'll tell you greater than or equal delta, and delta is between 0 and 1. Is it same one?
Delta is between 0 and 1. That's
okay.
correct.
Yeah, that's what I got. If I write the same equation, telling that greater than or equal to delta, and delta is between 0 to 1. It's same answer, am I right? This is same one,
Yeah, so I can write this. I can write the opposite. 1 minus this. So we just write C, whatever, probability greater than or equal to epsilon is less than or equal to delta. I mean, I'm not sure what.
Yeah, clear. Okay, this may be writing 1 minus because of that one constraint, that maximum one. I can do ulta. Okay, understood.
Yeah. So yeah.
To avoid that writing, that no, the delta is between 0 and 1. To avoid that writing, we can write 1 minus delta here, and delta is between 0 to. Okay, it's okay, clear.
See, okay, so the point is delta, why we're using the word delta here is because the opposite probability, we want it to be closer to delta.
Yeah.
Yeah, but again, you can always
sir, can I share my thought here, sir?
So you can always say 1 minus delta is eta, and eta is between 0 and 1. So leave, like it just.
Actually, I think this delta is the probability of finding the hypothesis that is erroneous, that contains error.
Yes. Yes. In some sense, it is right, because if you see here, this is the formulation that you can.
Yeah, it is actually in terms of probability of finding the hypothesis that contains error which is greater than epsilon.
Right, that's exactly what this statement. If you see, so delta is maximum probability that I'll find erroneous hypothesis. So I'm bounding that error in some sense by saying it has to be close to delta. I cannot cross delta. Yeah, go ahead. I guess Bhavani, you had a question.
No. I was about to share that same thought, sir. Why they're mentioning as delta? Because delta is that confidence. So it is like low. So it is that low of error number. Whereas 1 minus delta will be the accuracy. Accuracy will be always high. So that is why they had the delta in this delta with small error.
But
that is so.
Yeah.
Okay. Sir, one question. If you can go to the notes, sir, back. No. The ma'am's notes, lecture notes.
7.
The 7. Consistency, inconsistent. This formulas were there, right, sir?
Right.
If you can go to that page.
This one.
Okay, so yeah, scroll little down, sir. Yeah, this page. Yeah, here. So the H is equal to 3 to the power of n, because if the VC of H is 3, right, sir? That time it will be 3 to the power of n. If VC of H is 2, it will be 2 to the power of n.
No.
Is that?
So there's no VC, at least here. The idea is, see, what is the hypothesis space that you're considering? hypothesis space is H is basically a conjunction of n Boolean literals. Right. So what does it mean? It means I'll have n Boolean variables. Let's say I'll call it B1 to Bn. Let's say now their conjunction. So but also in their literals also. So I can one example of H of a H which belongs to this capital H is something like B1 and B2 bar and let's say B4, right? So this is a conjunction of literals. Now, but the point is, so how many such H exist in this capital H? That's what this is, right?
So it should be 2 raised to n, right, sir? Because usually if it is Boolean literal, it is 2 to the power of n.
No, because I can also not choose some literal some Boolean variable to exist in the hypothesis space itself, right?
Oh, okay.
So each Boolean variable can exist in 3 forms: either the positive form, that is B1, negative form, or the complement form basically, and not exist itself. So therefore 3 possibilities per literal. So therefore 3 power n for all literals.
Okay, understood, sir. Yeah.
And
Sir,
actually, it is a case of finite hypothesis space.
I'm sorry.
Yeah, this is a finite hypothesis space.
Correct. Exactly. Only
Yeah.
then
So therefore, that VC dimension is not applicable in this case.
And find out what is the shattering and all of that stuff.
Yeah.
Sir, one small doubt. Here I am talking about only one conjunction ka all space, am I right? Select like you written H equal to B1 and B2. So we are taking only one conjunction.
Yes.
See, I can have another and again good big space to be there. Okay.
Sorry?
Clear. Yeah. So it's only one conjunction, all the possibility.
One conjunction, all possibilities, right?
Okay.
So
Okay,
if I were to write, for example, disjunction of n Boolean literals, for example, so hypothesis space is the same, but the kind of hypothesis example would be, let's say, B1 or B2 bar or B4 and stuff like that. Disjunction is one other thing, whatever. Then you can see all possible things. Is that clear?
So here it is only with respect to find yes algorithm. That is why it is 3 to the power of n. Because otherwise, in many other lectures and notes, whenever it is n Boolean literals, the hypothesis space is always 2 to the power of n. So here we have that no value thing also, right, sir? For this, that is why it is 3 to the power of n.
See again. See, the point is finders algorithm is something else altogether. We are not discussing finders algorithm here. No, there is a hypothesis space. What is the number of elements in the hypothesis space? It's as simple as that. So hypothesis space is conjunction of n Boolean literals. How many such possibilities are there in H? That's it.
Yeah, because in different previous, I remember, sir, in previous exam or notes or previous lectures, ma'am was mentioning for same this formula was 2 to the power of n. So that is why we had one formula 2 to the power of 2 to the power of n. So we had that formula. I remember that.
So actually, in that case, you have another thing. For example, there is only 2 options: either to pick a ball or to not pick a ball. There is nothing called this negation there. So in that, you have only 2 options. So that kind of hypothesis may have 2 raised power n.
So in that case, what was H? We were saying all possible Boolean functions that are possible. So all possible Boolean functions, if you have, you'll have 2 power n.
Okay, and this is all possible Boolean literals. Is that what you're saying? So
conjunctions of n Boolean literals. Only conjunction, only and operation. I mean, I hope you understand what and conjunction disjunction is. Is that not clear?
No, sir. I'm little not able to recollect that.
Okay. So if you remember what and operation is, so let's say if there is a Boolean variable b1, b2, what is b1 and b2, right? If you remember, this is what we have. True,
Yes,
but you can write it in multiple different forms, but right. So this and is also called as conjunction. Another name of this, that's it. Okay.
Okay.
So, and so I can do this and in n number of variables, right? I can write b1 and b2 and b3, correct? I can do this n number of times. That's exactly what they're saying. That is the hypothesis space here, conjunction of n literals. Now, when you say Boolean literals, it means this b3 can be either I can write b3 or I can write b3 bar. Because literal, Boolean literal means it's exactly either the variable that you have, let's say a Boolean variable, or its complement.
Right, but even the same thing happens for that all possible Boolean functions also, right, sir? Even there, it can have B, even that is kind of a conjunction only, right, sir? Because that is also one kind of like option, like where B and B1 and B2 is one kind of option, and B1 and B2 bar is one. So it is same like that conjunction operation only here.
Right, but here the point is, if you remember, you have you want to know Boolean functions. Boolean functions means even the output also you can choose, right? So let's say I have two variables a, b, and there is some other Boolean variable c, right? Sorry, this is not wrong. So let's say, so now the point is each of these variables can exist once, I mean, it can exist either true or false. And then respectively to this combination, what will be here? Will it be true or false here, right? So now I have 2 power n possibilities here for this particular table, right? 2 power n
right.
possibilities here, and then for each of these rows, I can have a true or false. So 2 power n power 2 power n, because I have 2 power n rows here, and each of those
right,
rows
sir.
can
Might be, let's forget C, sir. Let's only consider A and B. It's similar to B1 and B2, right, sir? So which means I can have 2 power of n possibilities here. Let's for Boolean only 1 1 1 0 0 1 and 0 0. Right, so it is 2 power n. But there we are also considering no value as one option. So it can be positive, negative, or null, right? So here that is why we are having 3 power of n.
Correct. Yes.
Okay, so that is why I was confused. Only because conjunction is also, for me, it sounds similar to that of, and like even here I'm doing that conjunction operation only, but here I'm considering no value. That is why I'm having 3 power of n. So that is where I am little confused. Where will they use this no value, and where will they not use this no value? That is where I found that find yes algorithm has that no value thing, and that is where it has considered that option.
It comes up there, but it's not the only place, but yes, it can be used there. That's the idea.
Okay, understood, sir. Okay.
Can I say something here? Hello.
Yeah, SK, go ahead.
Hello.
So, right. Anything to add?
Right.
SK?
Yes, actually, I mean, my understanding of the the third possibility of no value is that in this case of A and B, just two variables in the domain, whether you are going to include B or not. For example, whether the output is a function of only A or both A and B. That is the third possibility. Is B included or not? And if it is included, then is it 0 or is it 1? That's how I understood it.
Right. I'm actually, yeah. I mean, yes, that's fine. Yeah. Is that clear, Bhavani?
Yes, sir. Yes, sir. It is clear. Yeah. Thanks.
Okay. Where were we? So question 13, I'll ask them. You know what can we do about it? Okay. Question 14. Any thoughts? I guess we discussed this very clearly. So the point is, we give higher weightage to the points which have been misclassified by previous models, right? And then they become more, prominent in the upcoming steps. All right. Then in AdaBoost, how are individual weak learners combined to form the strong ensemble? Again, we know this is the weighting the predictions of weak learners based on their accuracy. Again, this is straightforward from the AdaBoost thought process, right? I guess this is where we're coming to, right? Yeah. So we take the weightage of all these learners, but with some weightage, right? And the weightage basically based on their accuracy. Is that clear? Hello.
Yes, sir.
Okay. So week 8, any doubts you guys have with respect to k-means clustering or hierarchical clustering that you want me to?
Before going there, can we clarify that week 5, sir, which you
Yes,
just
yes.
put that in the notes?
Actually, sir, I have one doubt regarding this question number 2 in this assignment.
Go ahead.
Yeah, actually, it reads find the number of instance possible for x, and in the above in the description it is shown that x is the instance space. You are given
Right.
an instance space x given below. So,
Right.
as per the definition of instance space, it is actually a feature space.
Right.
Yeah, so we have only 4 features, and
Right.
this category is the target one.
Right.
Yeah, so while calculating the number of instances, we have to consider only these 4 features. So if we take color, you have 3 options. If we take shape, you have 2 options. Size also have 2 options. Texture also have 2 options. So it is 2 cross 2 cross 2, 8, and then multiplied by 3. So it should be D answer. The answer should be D.
Yes, Rahul,
Yeah.
we covered this question and we said the answer is 24. It has been already told to the NPTEL folks and they will correct it in a few days.
Okay, sir. Thank you. Okay.
Yes. Okay. Yeah. So you had a question, Bhavan. If week 5 is it?
So, no, sorry, sir. Q3, week 3, sir.
Week 3.
Actually, I have one doubt in week 5 question. First question. Week 5, first question.
Okay. Just a moment. Let's do the week 3. We are there right now. Bolo. What?
Week 3, question 9, sir. Whichever you have like discussed in the discussion forum. So, can you explain that, sir, little bit? So about content based.
Yeah. So see, the idea is in content based, we look at item similarity, but in terms of what those items are, right? We are looking at the features of these items. Let's say if you're talking about movie recommendations, right? We are trying to look at what movies are, right? I mean, how do you quantify a movie? Let's say you quantify, let's say using genre or using the plot or something like that, right? Just a moment, guys. Right? So we're looking at the features of the item. So we consider, let's say, 2 movies similar on the basis of, for example, let's say if they have the same genre, if they have a similar sort of plot details, etc. In this collaborative filtering, what we have, collaborative filtering, when ma'am said item based nearest neighbor or whatever, item based approach, there you don't look at items in terms of their feature similarity, rather you're looking at items, are they similarly rated among different users, right?
But
by
rating is also kind of feature, right, sir? So might be we can
no
consider that.
Again, yeah, so feature is anything is a feature, but the point is, again, the idea is we are looking at only users. So when you say items, so similar items, in the sense it is feature based sort of idea. Collaborative filtering, again, at the end it comes out to users only. We're not looking at items, their similarity, their feature similarity in any sense. So collaborative filtering is purely on users, similar users. All right. So that's the
so
way
it
you
means in collaborative filtering, it is with respect to only similar users, but ma'am was mentioning that considering similar users, sometimes users might be so huge, it is not practical. That is why we consider like similar items based recommendation.
Correct. Yes. So, but then how do you get how are 2 items considered similar in this framework of collaborative filtering is by ratings by the users. So at the end, it's the only decision driving features is only users ratings. There is nothing about the item as such. So similar items as such, when you say, it is not. So similar items means similar items in the terms of their feature space, in their descriptions or what they are, their attributes. That's what similar items would mean. All right.
Okay. Okay, sir.
Okay. Rahul, you had a question in week 5.
Yeah, actually, week 5, yes.
Week 5. Okay.
Week 5, first question.
Okay, go ahead.
Okay, so actually, the question is regarding to find the ideal complexity of a curve.
Yeah. So what? Eigencomplexity.
Yeah, ideal complexity, na?
Yeah, go ahead.
So according to this, the answer is A, which is linear separator or linear line. Na? It is a line. But as for this, you cannot separate the two classes because one of the points is still misclassified.
Right.
Yeah. So for the ideal complexity of the curve, you can have higher dimensional or higher polynomial curves which can cover this thing, this extra point. So actually, it may be possible to draw a curve which contains the points 100% on one side, and it may not be linear, but it may be of a higher dimension or higher polynomial. So that's what I'm saying. It is not clear from here that how it is possible to get an ideal complexity of the curve using this linear classifier. The answer is a.
Again, see, the idea here is we know that, I mean, the idea being that data is not always noise free, no? So very clearly, it seems that this point has been misclassified, or sorry, mislabeled for some what reason. So you're right that if you want to clearly separate these two, you have to go to some higher dimensional space where you can bring this point closer to these points and classify there. But would you want to do that? That's the question. Would you want to do that though?
Yeah, but as per question, we have to separate two classes using some ideal curve. Yeah, this is what it is given.
No.
So ideal word is really good.
So the ideal complexity is misleading.
Yeah, that's what actually. Otherwise, this question will be very simple. Why not one choose the linear one?
No. See, again, no. So I would say, see, ideal complexity. I understand the way you're trying to pose the question that okay, we want the complexity of the curve which separates the two classes as shown here. But I would say, see, try to see that this is not the point, right? The point here is if you have a small misclassification happening, a small mislabeling happening, would you want to still be? Would you want to separate the two classes? And let's say if this is the data given to you, you would still not try to do that because very clearly the point being that if you were to have if you were to try to separate the two classes completely, the learnt function will be very will have
complex, yeah,
overfitting, right? So obviously you would not want to do that. So ideal here means ideal in some sense that okay, can you do better in terms of the new data or something like that. So I understand from where you're coming from, but this is
but actually, yeah, as per this question,
not because of the concept, because of the language. Anyway.
Yeah. Actually, I am. That is not the case that I don't know. We can have a very little error if we separate it using a linear classifier. But the case is that to get the two classes separating using a curve which has ideal complexity. So, and the option it is given, you have linear, quadratic, cubic. So the answer could be that you can have other thing which will be insufficient data. For example, insufficient data, we don't know that what are the what is the scaling of these points. We can have a curve very well fitted within this. So you can have a ideal curve from which you can get 100% accuracy and as well as separating both the classes. So that is what I'm saying.
Right. Again, see, I understand that language may not be always right for many of the questions. But so if you feel that there's something that you want to hunt down, please make sure put it on the discussion forum. The course TS will get to you, because this is something that I don't agree with. At the end, you need to be able to understand that not everything. So let's say going forward, if you want to apply ML in real life scenarios, you will not get a clear language from anyone, right? Let's say if you're working in a company where you have to work with, let's say, some product managers and stuff like that, they will never be able to come to you with saying, okay, I want the error to be 0.2. I mean, that is never going to happen, right? So I would say take this as a learning to understand that language will always be ambiguous for any question for that matter. For this question also, I can come up with some other condition. Say, okay, the framing is right. So please take it as a learning. But if you still feel that this is unfair, go ahead, put it on the discussion forum, and the course TS will answer this question. Is that fine, Rahul?
Okay. Thank you.
Can I ask some question on VC?
I'm sorry?
Can I ask a question on VC?
VC, go ahead. Yes.
Yeah, see, I'm getting confused in VC. See, if you have 3 points, the VC is said to be, VC is the highest dimension of the hypothesis, am I right? Which can shatter.
VC is the number of points, I would say, rather, where you can do shattering in all possible labelings of that particular pattern of the points.
So the key word here is in all possible.
All possible, yes.
Okay. So I can understand, if you have 3 points, then right, there is a diagram which has been drawn that one line can shatter these 3 points, even if all the 3 are positive. Then right, they can be on one side, and on the other side, you can assume that it is negative or null. So this right, is fine. But the problem arises, when you have 4 points, say, and correct, all 4 are positive or negative, then many times can't you say that a line, a linear hypothesis is also a VC? Or you have 4 points, you need 4 points only?
No. So the point here is, so I'll take, for example, this 4 points. Okay.
Okay.
So if
say
all
are plus.
Sorry.
Or say all are plus.
All are plus, right? So now okay, I can draw a line here, not a problem. I can draw a line. I can say, okay, everything here is positive, everything below is negative, and it's clear. But okay, this is still not the VC. We haven't confirmed VC because we want to say for this particular pattern of these 4 points in this 2-dimensional space for this hypothesis of straight lines, are you able to solve for all possible labelings of these 4 points? Right?
That means all instances. That means for all instances.
No. Again, instances I would refrain. The idea being, you have these 4 points, right? All possible labelings.
Labelings. So that means 2 raised to power n. That means 2 raised to power for all 16 combinations.
Right.
Whether you can separate. Obviously you can't. It's very obvious you can't.
Correct. So right?
Therefore,
like this you cannot.
Then only a rectangle can do. You are saying.
I mean, we're not saying only a rectangle. A rectangle can also do it, but yes, the idea being that straight line will not be able to do it. But let's say I can have something like a quadratic curve, right? Sorry, okay, a parabola, for example.
Okay.
Right. Parabola I can have where I can do something like this. I can say, okay, a parabola, a parabola like this.
Right? Hyperbola, this is.
Okay, sorry, hyperbola. Oh my God. Yeah, hyperbola. Right. So hyperbola can solve this, right? So in that way, that's the idea.
Okay, so then my question is very simple. What is VC? Is the VC is 4? Means what does it mean?
So if let's say VC of H is 4, what does it mean? It means that there exists a pattern of 4 points in this whatever space that we have, right? where this hypothesis space will be able to solve for all labelings of these 4 points.
Okay, that means this particular pattern will be, that means a quadrilateral or a parallelogram or a rectangle, to be specific, or a hyperbola will be able to, in all cases, will be able to shatter.
Will be able to shatter. So again, see, all cases we were not saying there is a possibility that it will be able to do in one of those cases. Not all possible cases. We're not making that.
Then if it is one of those cases, then in that is my confusion which I get. If you say it is one of those cases, then this 4 points, the diagram on the top with a straight line, it is happening. So even that could be the VC, right?
No. See, again, the way VC is defined is at least for one pattern of those number of points, you should be able to solve all possible labelings, at least one pattern, if you're able to find.
Oh, let me just think. At least for one pattern, and the pattern is this 4 points, which plus minus.
Arrange this in this format. Now, for this pattern, if I can for all possible labelings, I can generate let's say this classifier, right? Then I would say that VC is 4.
Okay.
So one example that was there in this one, right? So let's say these 4 points, if I have arranged it like this, and if I use, for example, let's say these what do you call that, rectangles, right? Now, if I were to do something like this, I guess this is what we had, if I'm not wrong. So or I'm not sure, 1 second, something like this if I have, right, then in this case the rectangle will also fail.
Which in the rightmost thing.
Yes. So if you think about it, let's say and feel and others, please feel free to pitch in. So I think if I label it, let's say something like this, plus and plus and minus and plus. Yeah, correct. Right. So now here, if I were to draw a rectangle, right? If I said draw a rectangle such that all the points inside it has to be positive, I cannot draw a rectangle now, right?
Okay.
So hence,
only a hyperbola could do, but not even a hyperbola.
Yeah,
you could have a
that question. The idea, no, so the idea being that the rectangle, hypothesis space also is not able to solve for this particular example, but there is a pattern of 4 points where the rectangle is able to do all possible labeling. So hence the VC dimension will be more than or equal to 4.
Okay, VC dimension will be more than equal to 4 for what? For the hypothesis or for the pattern?
For the hypothesis. See, VC dimension is defined for the hypothesis, no?
And hypothesis is the classifier.
So yeah, so here the hypothesis is rectangles, basically rectangles such that all the points within the rectangle are positive. Let's say we define it like this.
Okay. Okay, thoda confusing here, but it will settle down slowly, because it is, it is like, I mean, whether it should be for all the patterns or it should even, there shouldn't be even a single exception, that becomes a point of contention.
So I would say it's at least for one pattern. At least for one pattern, if we are able to find a hypothesis, if there exists a classifier, right, which can do for at least for one pattern for all possible labelings of that pattern, then the dimension will be greater than or equal to the number of points in that pattern, which is 4 in this case.
So what is constant is the pattern.
Yes.
And what is constant is the pattern. You are changing the labelings, and now your labels, and now you're going to trying to find out a classifier which can shatter.
Which can shatter all
at least all possible points.
So in
all possible labelings,
possible cases of labelings, it is able to shatter that particular pattern of points.
Yes. So for a given pattern and for with possible labelings, there should exist a classifier which is able to shatter all possible labelings.
Yes. Yes.
समझ गया, ठीक है?
Yeah. So
hello.
I would say just look at the examples carefully a bit more in the same week and material. You'll be able to figure out where the things are and just try, for example, these two sort of examples, right?
She has said that that 5 points cannot be even shattered by a rectangle.
So I would say try it एक बार try करो कि why, let's say if I have any 5 points, if I take, I cannot shatter using this rectangles one. Try it out. If not, we'll try in the next class together.
We are having a next class on Saturday.
Sir, week 8, I have some assignment 8. I have some discussion.
Sorry.
Dendrite, that in week 8 assignment, there is dendrograph. There was one option. Can you open it?
Yeah, 1 second.
So one of the again option is also correct by looking at the type 4. No, below one. Below there's
this one.
No, second one. Yeah. No, second one.
Second question.
No, not second question. Second diagram of dendrograph. Below.
Oh, okay. Okay. Fine.
Yes, this one. So here the option 4 is also valid. That validity if we check, but although answer is D, yes, that's a confusion.
I'm sorry.
Like by given of dendrograph that we are able to conclude that 4 is the cluster for best option if we need to opt, because length are more. Hello.
Okay.
So that option is also valid, that I'm saying, although I'm aware that D option is here, but that's the confusing point. If we need to opt, if somebody is choosing that B option, that is also correct. That's I'm just want a discussion on that.
Fine. So let me talk to the course TA. If possible, we'll make it a multiple choice. Then, if you feel multiple are right, then we'll have it a multiple choice.
No, I'm just want your thought in this question. What you conclude that?
I cannot give my thought because this is not submitted yet, right?
No, not in the answer. Answer I'm not asking, but is it as in general? Let's take another dendrograph, and can we?
Then let's say you want clustering on the data set and but what is the measure that we have here? Do we know the measure though on the y-axis?
Label are given now. If number are not there, then we can't say, but numbers are there.
No. But I mean, see dendrogram, but with what link clustering and all of that, no? So how will we get to know what is the best clustering?
No, for a given how we can best clustering length, vertical height we check, no? It should not cut any like branches, like where maximum vertical height we get, that we choose as a best cluster number of cluster. That is the way, I think, as per
the this
what
one,
I found in net over I blog. I studied that what dendrograph about.
Okay.
So how to choose the best. So that is the method they mentioned. The vertical maximum height we get, there we cut. And one more confusion point is, suppose it is cutting somewhere like a pairing up one cluster and another point they are saying as a singular point or some other name. I am not exactly remember, but they are not saying it is as a cluster. But in that lecture series, they have counted as a cluster, individual point, which are not paired directly. They went to the root. So which one is, that's why I get confused in terminology. They are in net or other lecture series, they don't say as a cluster. They have given some another name point. I'm forgetting just the keyword. Singular point or some, yes.
Okay. Sure. So again, so I don't deal with this every day. So in the next class,
just next week, just
go through it and come back. Not a problem. Sure, we can discuss on that. No problem.
Okay.
Sure. Sir, regarding week 2 assignment, sir. So you have like for one question you have mentioned in the notes your discussion forum that there is for week 2 question 11 we have 0 points. So just curious, like okay, 0 points means we have discussed that before. So is that in case if we get this question, the right answer would be A and C, right? No, it is only A, right, sir?
Only A, yeah, only pruning. Only yeah. So decreasing doesn't make sense. Increasing, then right. a number that will handle overfitting. Yeah. So pruning is the right answer. Only. Yeah.
Okay. And assignment, okay. And week assignment 4:15, sir. Assignment 4.
Assignment 4. Question 15. Yeah.
Yeah. Here, for the answer C, I remember you mentioning about something, sir. Like because this, when we see in the internet, we see that this answer also is correct. But why not this option C is right, sir? Because name.
No. So handle missing values. You have to either remove those points in the data set. So I've asked the TA to improve the answer. So I think because in the solution they haven't, I guess they haven't mentioned it cleanly. So where is it? They're saying incorrect here. Great. Yeah, it doesn't correct. So need to be handled. So I've asked them to mention more detail, like how handling has to be done, etc. So one thing is that you generally remove those points from the algorithm and you do it. That's one way of handling. So I would so we'll try to get those details here, right? But handling missing value without any special treatment, I don't think that is the right way of putting this. You need to do something about it at least. That is either removing or creating a new class also is basically handling specially only, no? Because I remember we had the discussion where we said, okay, we can handle it as a new class, but again, that's just handling with some
continuous case, sir. No,
I'm sorry.
In continuous case probability CTF, we can handle it without any special.
No, but how would you handle
continuous
in continuous case also? How would you do it?
Just if we have a model like so intermediate point we can take. If we have assumed there is a continuous Gaussian, so in between point we can like no need to through model we can take.
No, but what will you fill in that space when you say Gaussian?
So the Bayesian curve, like suppose some values, na that is a probability model thing. But in internet also we get the same answer. Like there is C is correct, but that's why the continuous is the answer for it without specialty.
No, but I'm not able to understand. Even if it is continuous, how would you handle the missing value though? You're saying you want to impute the value.
We have some model, na, then we can in any point it is defined. Continuous means we can interpolate without any extra work. Isn't it?
No. I guess we are speaking
some function e to the power x.
No. Leave function. Let's say there's a probability model. Okay, leave the exact this one. Okay.
Probability model is also in continuous case. Now we handle CDF like continuous case, and discrete is a PDF. That discrete case is PMF. Probability mass function and probability continuous function. That is also probability, isn't it?
Correct. Yes, probability. Now, so let's say there is some feature number x6 and you assumed a probability distribution over the feature x6. Okay. Now, in your particular test example or your training example, let's say some x6, whatever the fixed feature was, it is NaN. Now, how do you handle it? What are you saying about?
This is the one case, but in question is the like for there is another sample. It is for discrete case, that's okay. But if there is a continuous case, it is answers would be valid. That validity is the, because in MCQ we have to think all cases. We cannot take particular one counter like one case and say it is failing there. I'm also giving an example where it is satisfying. So this is our thought process.
No, I'm confused with the example itself, Jitendra. When you say continuous, let's say x6 is continuous. So what? So okay, if it is missing, now what do I do? According to your approach.
X is missing means no probability model. I'm just giving a probability model is our Gaussian sum. Suppose we have some mu and sigma. If you give some x, we can find the any probability. That's why I'm asking.
Sigma. Okay. Now, yes.
Suppose it is following that probability model, this mu sigma. Right. If you are asking for any point, what is the probability? I can, by this Gaussian, I can tell the answer.
See, Jitendra, x6 is missing here. So what do I do with this? You're not answering the question.
Sir, can I clarify this?
Yeah, go ahead.
Just what I'm just thinking, what he's saying. See, the data sets will be not got in this particular order. See, what he's thinking that the x6 can be filled with the, if you have the full data, but data set will not come in the particular order. The output can be a Gaussian or whatever. This is the feature is missing, so we can't take the average because there is no formula to directly interpret this x6 value. He may be thinking that I can make an apply a formula, then I can interpret it. Am I right? I think he's thinking like that.
Yes, for particular case, that's I'm saying. I'm not saying all cases.
In general, data will not come in the particular order. Output can be, but the data, no, the input data is not either randomly selected or it may not be order. It's not following some sequential order actually. So we can't interpret.
That's why interpolation functions we use. Yes,
that interpolation you can't apply here because it is data you don't take in some particular order. Got it? No, the data can be in any order actually. Output can be some order.
Yes.
We arrange it, but input cannot be. So missing is input feature. Am I right? That's what he's telling. You can't interpret it. Am I able to answer your question? I don't know. That's what I understood.
Okay, fine.
You got it, no? Even though the mu and you can apply it, if it is some order, it is there actually. Some pattern, it is there. But input you can't expect in the pattern basically. The output can be in the pattern.
Okay, so see, if you say
actually, that time I was not completed. I just Googled that Naive Bayesian and there it was saying. So I didn't go much into detail, but now I will look into it again and let's see.
Sure. Yeah.
Certain blog I just Google it that time.
Sure.
Sure.
Yeah. Anyway. So yeah, please do that. I mean, so because I'm not clear as to how you would how would you handle this case, even if you have, let's say, a probability distribution model. But what can be done though is we can make the answer a bit more clear. So that can be a bit more clearer.
Yes, for the exam at least it will help if same question comes.
Sure. Yes, that is sure. Yeah. Okay. Any last questions?
Sir, I have a question regarding KNL. Okay. So can you please open the week 3 tutorial?
Week 3?
The PDF lecture material.
Lecture notes. Okay.
Please go to page number 13.
13?
13, 1-3.
Okay.
Yeah. So here at the bottom, so what is this e to the power kernel width into distance metric given there? So what does it mean, the kernel width?
So that's exactly this one. So I'll give you an intuition. So let's say there is a distance metric. For example, let's say I use something like this, some xi minus xj squared, and let's say by some alpha, right? So now, if I were to use only xi xj norm squared, let's say, right? Now, if let's say xi and xj are let's say this values, for example, let's say some 2 or something, right? So this exponential distribution will give something like this, right? We'll say, okay, it is closer with respect to some value, right? Now alpha helps us tune, change this shape of this distribution. That is, I could do something like this, right? So I would say then that this point is more similar than compared to, for example, let's say in this particular scenario where I don't use something like a kernel width. So kernel width actually talks about what is the width of the, actually speaking, in some sense, the distribution of this distance function on the point, right? So having a higher kernel width or lower kernel width basically changes the effect of that value at the end of the day. That's what kernel width means, and that's what it's saying. That it basically controls the size of the neighborhood that has a large effect on the value. That's the idea of kernel width.
Okay, please go back to the previous page where you have drawn the image. Where you have drawn the image.
Image. Oh, this one.
Here in the second one, the lower one is the kernel width, the maximum you are stretching the graph.
Yes.
That
so
is the kernel width.
The graph, correct.
How much you are stretching it?
Yes.
Okay.
Yeah.
Thank you.
And you can also have, same, in a similar format, you can have something like this, right?
Yeah.
And you'll say, okay, it's not very similar. So basically, this width is what you want to control. That is done using this.
Yeah. Okay. Okay. Got it.
Yeah. Anything else? Any last questions? So I'll confirm on the discussion forum regarding the next class, which we are hoping to have it on 21st September, 6 to 8 p.m. All right, I'll confirm on this one because I need approval from NPTEL to do that and everything. All right.
When are you planning, sir?
So 21st September, no? Thursday.
21st September. Yes. Okay.
6 to 8 p.m. we'll do there. So we'll discuss week 8 answers and any general questions that you might have before the exam. All right. Okay. Let's meet in the next class. So, thank you guys.
Okay. Thank you, sir.
Sure.